Hello, everyone. This is Dr. Niladri Chaudhary and President of Green Computing Foundation. And today with us, we have Dr. Anand Shivapuji, and he is taking care of a new initiative and a new research that has come out on using of biomass for energy production. The reason for having this particular session is to let the people know how important it is to go for renewable energy, and more so a stable renewable energy. So I will hand it over to Dr. Anand to introduce himself and say a bit about what they are doing in this initiative.
Thank you so very much, Dr. Niladri, for this opportunity. Indeed, it is a very pertinent platform to spread awareness about technology that we are into. Having said that, hello everybody. This is Dr. Anand Shivapuji. Currently, I am donning the role of Senior Research Scientist at Indian Institute of Science. Concurrently, I also am one of the founding directors of a company called as Carbzob Solutions Private Limited. This company has been brought into focus primarily to commercialize all the technologies that we have developed at IISC, addressing the broad spectrum of decarbonization. that is broadly about me and what exactly we do at IISC and per se at Carbzob Solutions Private Limited is we broadly look at sustainability as the foundation for all research activity, and more so we look at bringing in decarbonization as the essence of sustainability, because sustainability has got multiple spheres. Our focus definitely is on decarbonization. The way we are approaching decarbonization would require a little bit of background about what we are doing and how we are doing it. If you really look at the environmental scenario today, significant amount of carbon dioxide has got accumulated in the atmosphere. And if we really go back historically, then typically about 350 parts per million of carbon dioxide has been the average acceptable level of carbon dioxide that can persist in atmosphere over a long duration. And so long as this level is maintained, nature generally remains kind to humankind as well as the general vegetation and animal population around. However, over the past 200 years, what exactly has happened is with the industrial revolution setting in somewhere from around 1800s and so on and so forth, because of anthropogenic activities, the amount of carbon dioxide that is emitted into the atmosphere has now significantly increased as compared to the carbon dioxide absorption potential of Earth, both in terms of vegetation as well as in terms of oceanic absorption. I'm sorry. So, what has happened over the past 200 years is, while the general comfort level of carbon dioxide in the atmosphere has been 350 ppm, today we are looking at somewhere about 420 ppm of carbon dioxide. So, somewhere about 60 ppm of carbon dioxide is in excess. Now, all the variation in the environmental or atmospheric pattern, in the weather pattern, especially in terms of precipitation pattern, is attributed to this particular excess 60 ppm of carbon dioxide that is persisting in the atmosphere. Sometimes we have severe droughts. So during summers, our temperatures are touching and maybe crossing 50 degrees. On the other hand, we have extreme downpours leading to catastrophic scenarios like what has happened more recently in Kerala. And this is not unique or specific to India, it is happening across the globe. So, if we really look at it, the problem on hand is we have 60 ppm of excess carbon dioxide that is percolating in the atmosphere, which on absolute terms actually comes out to many gigatons of carbon dioxide. We are only talking about parts per million, but in absolute terms, it turns into gigatons. So as a scientific community, we now need to initiate actions which actually pulls down the 60 ppm of carbon dioxide from the atmosphere and then brings the average carbon dioxide in the atmosphere again to somewhere in the 350 ppm level. So if we really seriously want to address this issue of climate change, this is something which we have to do. We don't have any choice on that, at least on the long term. Now, the way this climate change is being addressed and the way decarbonization is being addressed, one of the solutions that is being really looked at is to generate hydrogen and then use it for all applications by displacing fossilized hydrogen and carbon. While it is a very good initiative, one of the challenges that remains in that particular scenario is we may be displacing use of conventional carbon, but then are we taking steps to actually reduce the carbon dioxide in the atmosphere from 420 ppm all the way to 350 ppm? That still doesn't seem to be happening. And unless we do this, I again repeat, we are not going to land up anywhere because the weather pattern will continue to remain as bad as now. So scientifically speaking, we need initiatives which will ensure that carbon dioxide levels are brought down from 450 to 350, from 420 to 350 ppm. Now, this requires two things to be done. First thing is we should now immediately stop emitting more carbon dioxide into the atmosphere. Action point number one. Action point number two would be somehow remove the carbon dioxide that is already present in the atmosphere. Now, at Indian Institute of Science, we have actually approached the problem of decarbonization considering both these scenarios. So what we have actually done is we have considered biomass as an energy resource in order to address this problem of environmental carbon dioxide persistence. Now, how exactly does this help? One very important thing to be noted here is whenever biomass grows by means of photosynthesis, it naturally consumes carbon dioxide from the atmosphere and fixes it in the form of solid carbon. To give a sense of numbers, for every kilogram of biomass that is grown or vegetation that is grown, almost 500 grams of solid carbon is present in the biomass. Now, to fix 500 grams of solid carbon in the biomass, close to about 1,900 grams of carbon dioxide will be pulled in from the atmosphere. So, for 0.5 kilograms of carbon that is present in 1 kg of biomass, 1.9 kilograms of carbon dioxide are actually pulled from the atmosphere. So, here you can see the beauty. When every time we start growing biomass, we are actually trying to pull carbon dioxide from the atmosphere. Then, if we have a technology which enables extraction of energy from this biomass while releasing less amount of carbon dioxide back into the atmosphere, then what happens is over a period of time, we continue to draw in more and more amount of carbon dioxide from the atmosphere while also satisfying the requirement of energy for a variety of our industries. So for us, the philosophy is make use of grow biomass, absorb carbon dioxide, use this biomass to generate required energy. It may be thermal or electrical energy, and the process should be such that the amount of carbon dioxide released back is less than the amount that is actually taken in during the growth phase. That way, over a period of time, we are ensuring that no carbon dioxide is released, but carbon dioxide is absorbed from the atmosphere over a period of time. If this technology that we are promoting is adopted across the globe, then maybe over the next 100 years or so, the carbon dioxide levels in the atmosphere will again come back to 350 ppm. So that is the broad philosophy that we are adopting. For us, biomass, bioresidue is the raw material, and that will be converted into energy, and that will ensure that carbon dioxide is fixed from the atmosphere, enabling decarbonization initiatives. So broadly, that is what we do.
Great. Thanks. It was great to understand. So what we look at is that plantation as well as the conversion to energy both goes hand in hand, and that's where it gives the overall picture. I
Absolutely.
was just going through some of the figures in India, and I see that currently uh, wind energy in India is around
Hello.
46.65 gigawatts. Solar is around 85.47 gigawatts, and biomass related energy is around 10.35 gigawatts. So there's a huge scope for improvement.
Yeah.
And currently, I think it is around 32% of the overall energy that is produced. Now, Green Computing Foundation is basically into the area of promoting sustainable IT. And you know that IT is a significant contributor to carbon footprint. And if you look at every organization, everything is automated. Everybody is using some digital device. So there's a huge amount of carbon footprint that we are creating. And
Yeah.
that is where we partnered with you so that we can bring in these knowledge to our community, to our practitioners, that how can we work together and bring a situation where we have less carbon, we actually start reducing carbon rather than neutralizing it. And that's where I would like you to explain uh, that how is this method that you are saying is better in terms of reducing carbon compared to the other renewable energy, because we just saw the figures. Currently more people are focused on uh, the solar panels or windmills, some hydro. So how is this method going to be much more better in terms of the entirety?
Yeah. It's a very nice and pertinent question again, Dr. Niladri. Uh, if we really look at the decarbonization initiatives, we have a basket of solutions, which you also rightly pointed out. And two of the major renewable solutions are solar and wind. Now, if you really ask me how they are better, or how our technology is better than that, I would like to make a humble submission here that when we really look at decarbonization as the broader goal for humanity, it has to be a complementary effect rather than a competing effect. So, due credits are there for wind energy, due credits are there for solar energy. They have a very major role to play. Purely, purely on technical front, one of the major advantages that our technology has and can be claimed is that as far as wind energy is concerned and as far as solar energy is concerned, the availability is entirely left at the mercy of nature. If you really look at it, even on the best of the days, we may have about 6 hours of solar energy, and the wind energy definitely is pretty intermittent. Combined, both solar and wind energy, maybe we are today touching somewhere about 50% of the plant load factor. So let us say you install a 10 megawatt plant in a appropriate mix of solar and wind energy over a period of 24 hours, maybe 50% would be the plant load factor, because during shade anyway you will not get solar energy, and there will always be phases of lean wind when the wind turbines do not generate power. So what exactly happens is, while the end utility, the energy consuming segment continues to run 24 by 7, especially when we are looking at data centers and IT infrastructure, they run 24 by 7. The renewable energy mix today is not able to completely satisfy the requirement, because the generation is at the mercy of nature. When it comes to our technology, since it is based on bioresidue, which is a solid fuel, what exactly happens is exactly like the way today we are planning for thermal power plants, wherein we can actually create inventory of fuel and ensure or plan generation of power for maybe next 7 days or 10 days or whatever. in exactly the same fashion, following the established model of fuel aggregation, bioresource can be aggregated, made available at a particular plant, particular location, and 24 by 7 green energy can be generated. So that is the most important advantage of the technology that I am speaking of. In that, it is going to provide you 24 by 7 green electricity, which the other technologies may not be able to provide. So this is one of the key differences and advantages as far as the technology is concerned. And the other major advantage of this technology is this particular technology converts biomass into a mixture of gases, and these mixture of gases are sent into an internal combustion engine. So typically what happens in this particular route of energy conversion is that depending on the end load requirement, the system can easily follow the loading pattern. So in case you have 75% requirement of the load, then the engine can be operated at part load and it will deliver you only 75%. In essence, suppose during a particular phase of time, all your requirements are being satisfied by, let us say, wind and solar, then at that point of time, the power generation from the gasification technology can be scaled down and it can be scaled up again as per requirement. So, load responsiveness is an inherent strength of this technology, along with 24 by 7 green energy provisioning that can be made. So, that is how the technology differentiator and technology USP can be established.
Great. So, as you rightly said, that we need a stable energy to actually use the other renewable energies which are not stable enough.
Absolutely.
And that is where coal and gas always has taken precedence. And now we have this biomass produced gas related energy, which
Yes.
creates that stability without the bad effects of the coal and give you that stability on which you can also complement the other renewable energy like solar and
Absolutely.
wind and so on.
Yes.
Great.
Yes.
Uh, just to out of curiosity, if I may ask, if to let us know, so what are those which becomes the inputs to this process? What are the raw materials, and what is the process that it goes ultimately in creating this?
Okay. Uh, the technology what we are talking about is called as biomass gasification system. And as the term gasification is broadly indicative, we convert biomass or bioresidue into a gaseous mixture. Now, this gaseous mixture typically contains compounds like hydrogen, carbon monoxide, and methane as the combustible components, and it also contains some amount of carbon dioxide and nitrogen as the inert media. Now, when it comes to the source, the beauty about this technology is the system or the gasification technology broadly remains feed agnostic. You can make use of any type of feed on a predefined criteria of ash and moisture content specification. What I mean to say is any feed that can be brought into the shape of a briquette or pellet, that essentially means densification. And so long as we can maintain or control the ash and moisture content to under 20%, anything can go into the system. It is not really a close function of the feed that goes in. So effectively, that makes it nearly feed quality or nearly feed independent. So if we really look at the entire spectrum of our country or even international arena, any crop can potentially become a source for this particular technology. Only criteria would be the ash and moisture content together should be preferably less than 20%.
Okay, so I was just reading that recently government of India has put their pricing benchmark of 2 rupees 27 paise per 1,000 kilocalorie.
Yes.
And we have also specified that the calorific value should be 2,800 to 4,000 kilocalorie per kg.
Yes.
And they also have specified that less than 14% moisture content.
Yes.
So keeping all these things in mind, my next question is twofold. First of all, what are those things that can be used for making those pellets? Like when we visited your site, we saw that sugarcane was one. So I'm assuming that sugarcane, coconut, the coconut
Coconut
thing,
shell. Yeah.
uh, cotton things, husk. Is there any other things that can be taken up as the inputs? Number one. And number two, how does it fare with respect to per kilowatt cost compared to the different renewable energy source?
Okay. Yeah. When it comes to the source, as I was mentioning, this particular technology remains feed agnostic. So you can make use of something as light as corn cob, because today corn is also being grown in a major chunk of land, both in India as well as abroad, especially in US and Brazil. So corn cobs as light as corn cob, then as heavy as bamboo. We can use straw of practically any of the pulses. We can use twigs of twigs of cotton stalks. So we can use palm. We can use practically any vegetation, any overground vegetation, which can be brought into this particular shape of briquettes, which can basically be densified. Now, the reason why I say this is so is if you really look at it, all the vegetation is all the vegetation grows solely on the basis of photosynthesis. So photosynthesis is the process wherein light along with some of these other atmospherically persisting gases are used and then converted into some of these higher chain compounds like glucose and so on and so forth. So really speaking, all biomass broadly has got similar composition. However, their form, their shape, their density may be different. That is where once we bring all these things together in the form of a briquette or a pellet, then it really becomes feed agnostic. So typically any residue that can be briquetted and the ash and moisture content can be brought within 20% is a potential feed for us. There will be no reject or anything like that. That is on the feed side. Insofar as the pricing is concerned, one of the key things is if we really look at, let us say, today generators operating on diesel, because there are quite a bit of emergency power generators or even continuously operating power generators which are operating on diesel and on natural gas. Now, if you really look at it, every kilowatt hour of energy that is generated using diesel generators emits about 630 grams of carbon dioxide. Whereas if it is methane, then the emission comes to about 550 grams of carbon dioxide. Now, this particular technology that we are talking about can actually fix approximately around 60 grams of carbon dioxide into the ground. So you see, against 500 and above grams of carbon dioxide that is emitted into the atmosphere, we are actually fixing almost 60 grams of carbon dioxide into the ground. So this technology has got a niche to it. Okay? Having said this, now typically when it comes to the cost of electricity generation, every kilowatt hour of electricity can cost approximately about a rupee or rupee and a half as operating and maintaining cost, excluding the cost of feed. Okay, so if you keep aside the value, cost of feed, then about a rupee or rupee and a half will be the cost for 1 kilowatt hour of electricity. Now, for generating 1 kilowatt hour of electricity, you require somewhere about 800 grams of biomass. 1 kilowatt hour can be generated in about 800 grams of biomass. Now, if we really look at this 800 grams of biomass, it can cost somewhere in the range of about 5 rupees to 6 rupees, and that is the kind of costing. So what we are looking at is for a 24 by 7 green electricity which can fix atmospheric carbon, the cost of electricity can be in the range of about 6.5 to 7 rupees per kilowatt hour. That is the comparison.
Okay. Great. So, when we look at the current scenario and we see that already this is being used by manufacturing concerns, um, so if you can give some examples of where it is used, and is there any example of uh, data centers or IT uh, setups or campuses or anybody using it so far on this? And if they have to do it, how do they go about it?
Okay. This technology has been exhaustively used for both the thermal and electrical energy generation. Having said that, one of the key features of this technology has been that whenever it comes to generation of thermal energy, most of the plants have been kind of captive power plants. That is, thermal energy generated and then consumed in-house. When it comes to electrical energy generation, uh, uh, different capacities of plants have been operational over course of many years, wherein the power has been pumped into the grid. So this could essentially be because of certain economic advantages and because of some grid synchronization issues and so on and so forth. Typically, because generation runs into few megawatts through these systems, and it is always at 440 volts and above. I mean, this has got more into the electrical and electronics aspect of it. When we generate power, then rather than just directly connecting it to the end utility, it makes more sense to actually pump it into the grid at higher voltage levels. So, from that technical perspective, what has been really done is over the course of time, many plants have really seen the light of the day, wherein electricity has been generated and has been pumped into the grid, and then from then onwards, it gets distributed to various end utilities. So, when it really comes to data centers as an isolated or captive power plant, no, I am not in a position to give a specific example like that. But this technology has been feeding in green energy to the grid over a long period of time, thereby contributing to making the grid green.
Okay, so if any organization specifically would like to use this, like many companies set up their own solar panels and so on, um, if they want to use this instead of solar panel, how do they go about it?
Yeah. What really has happened is, as a part of faculty entrepreneurship program, which is promoted by Indian Institute of Science, we at IISC have actually established a company by the name Carbsorb Solutions Private Limited. Now, this Carbsorb Solution Private Limited is the exclusive licensee for all the technology that has been generated by our group. So this particular company forms the platform through which commercialization can be taken up. So we can make an assessment, and what exactly we have also done is, since we come more from technology side, we in turn have identified our licensees who will actually be who have a lot of expertise in construction, operation, maintenance. So the basically the entire EPC game we actually are allowing our licensees to handle. So we have a well laid out pathway and structure in order to ensure that this technology can actually see the light of the day. And another thing also that is possible is, through this company and through our licensees, options are open both for EPC model, wherein the capex is on the companies which are investing. Operating maintenance can be taken by us. The other route is, it can be on a BOO model, build or operate basis, where the company pays only for the service. So that way we are giving the flexibility for the operational things, and we are also taking up the onus of the supply chain of biomass. That way, if any company is really looking at complete greening of their energy matrix, we can take up the entire responsibility of
Great. So, what I see is that government is quite interested in and showing a lot of enthusiasm in trying to expand the biomass generation. And for
Yes.
that matter, actually, they are also going ahead and saying that increase the plantations of specific types of trees like the neem and all, which can be used well, and
Yes.
even things like bamboo, uh, which is low maintenance, but that can be used for uh, the increase in the production. So if I look at it, is it possible to create a kind of a CSR project for various companies, IT companies, where they bring up this tree plantation of specific types, which gives this, and the biomass energy in the process, the biomass generation can come up, even like solar panels that can go into the grid, need not necessarily be directly coming to the organization, but have that biomass plant set up somewhere, trees grown, and in the process get that carbon credit out of the whole thing, and can it be a CSR project too?
Absolutely, we are completely open for that particular activity. As a matter of fact, some discussions have already been initiated in the Orissa, Jharkhand, North Andhra belt, which is predominantly a tribal belt, wherein there are some NGOs which are working along with the forest dwellers who are actually permitted to aggregate certain resources from forest, and we are actively working with them to actually provide village electrification, because grid connectivity there still remains a little patchy. So what we are looking at is we are creating small islands of our technology, allow the local population to actually aggregate certain bioresources which they are permitted legally to do, and then operate this particular facility on need basis to catering to their own requirements. So that is definitely possible. That is a purely CSR model wherein the energy is going back into the society. Similar kind of thing can be replicated for completely greening at least a segment of maybe a data center or something like that, wherein it runs completely on this particular system. We can actually showcase the extent of carbon footprint reduction, maybe per teraflop or whatever terminologies the data centers use over a period of 1 year or something. That is perfectly doable. We are geared up for taking that.
Sure. Great. So my last question is, um, that now that we are generating a good, cleaner energy, is there a possibility, or are you working, or is it already done in terms of uh, also as it is created to store it so that it doesn't get used immediately? Like, for example, just to give you an example, let's say the center is running on a renewable energy. Now, because of the non-availability of sun or wind, now is the time when it has come down. So that is the time when we are using it full. But when the others are there, that is the time, even if we are producing something, is there a way that we store it?
It's a nice question. See, basically, what we are looking at is a agro residue as a feed for this. Agro residue pellets or briquettes. Now, these agro residue pellets or briquettes have a shelf life of years together. So, is as simple as either operating or not operating a diesel engine. So when you don't want your power, just either derate the diesel engine operation or switch it off. Similarly, our system can also be operated in that particular mode, wherein if the energy is available from alternative resources, we can actually scale down the performance of this. The biomass will continue to be residing there without getting affected. So the way I see it, energy continues to be stored in raw form rather than post generation in the form of some electricity or gas. That way, it is much easier for management.
Okay, nice. I think that again is another advantage compared to the solar and wind and hydro, because that's continuously flowing. So as it is happening, you do it. You cannot just stop uh,
Absolutely.
there. But here you have the option of not using it when it is not required.
Absolutely.
That brings me to the point that uh, when we are generating this, you said that the pellets or briquettes are being used and it is burned to get the. So, is there any amount of gas being again thrown out into the environment? and what percentage will that be?
It's a very nice question. See, basically, in the process of generating gas, there is no emission because the entire process happens below atmospheric pressures. So during the process, no emission takes place. However, once the gas is generated and once the gas is sent into an internal combustion engine, in the internal combustion engine or in an industrial burner, carbon will get converted into carbon dioxide. Now, here the beauty is a significant chunk of energy comes from hydrogen. So hydrogen will get converted into H2O, so there is no problem with that. Balance, whatever energy comes, is coming from carbon or carbon monoxide getting converted into carbon dioxide, and that is left back into the atmosphere. Now, the beauty here is that since this carbon dioxide is coming out from biogenic resources, the carbon footprint associated with this is zero. So no greenhouse warming effect is attributed to carbon dioxide emitted from any conversion of vegetation-based carbon. The other thing is one of the byproducts of this particular technology is solid char. So whatever biochar is there, that is another byproduct from this, and that solid char actually represents carbon sequestration. So we are generating biochar that is representing carbon sequestration, and this biochar, whatever is generated, has got an extremely good nutritional enhancement value for the soil. So hypothetically, if this technology is established in some area where it is accompanied by an energy plantation, then the char that comes out can actually be used as a nutrition for growing the plants, cutting down on the need for synthetic fertilizers. So that way, this particular technology has at the most zero carbon footprint, at the best negative carbon footprint.
Excellent. Thank you, Dr. Anand, for this insightful session. And I'm sure the community, the practitioners of IT will be able to gain a lot from here. And we will also try to promote about this use of this technology, use of this product for better bringing the negative aspect of bringing down the negative aspect of carbon footprint that IT otherwise is creating. Thank you once again for this insightful session. And I'm sure if people would like to discuss further with you or visit your lab, they would be they will be able to contact you and connect with you.
Sincere thanks for this opportunity to speak to you and then put through our ideas. And also, I would like to use this occasion to extend a open invitation to all members who would be interested in actually witnessing the plant operation here. We have a 100 kg per hour plant which can generate close to 125 kilowatt of electricity every hour. We also have this facility to be in a position to generate hydrogen too, because a small variant of this technology can also generate hydrogen. And we have facilities like internal combustion engine for generating electricity. We have fuel cells, we have industrial burners. Basically, we at our lab, we have the entire set of facilities which can showcase decarbonization through biomass route. So we would be more than glad to accommodate people who would like to witness this in person, and we can have some sessions for visit over a period of few hours. Thank you so very much.
Thank you.